Hi, this is Team 25, grinding gears, and this is our clay pigeon thrower.
Pull.
The original clay pigeon thrower has a high required input force to cock the device. This can become strenuous after multiple uses or cause difficulty for some users. A demonstration of the existing problem follows.
As you can see in this demonstration, for the average user it's very difficult to cock the device. The amount of force that has to be applied to the arm in order to rotate it around to the locked position exceeds what's comfortable for most users.
The main goal of the redesign is to lessen the amount of input force required by the user in order to operate the device. But with this, there come several other requirements. In order to maintain the original functionality of the thrower, any modifications made cannot interfere with the throwing motion to launch the clay target. The device is also meant to stay within the original product classifications of a manual clay pigeon thrower while also improving functionality. And last and most important, the new design must also abide by the same safety standards as the original product.
This device is the prototype for our redesigned clay target thrower. In order to lessen the required force to cock the thrower, a system was designed to create a mechanical advantage for the operator. It was determined that a worm gear would drive a spur gear to rotate the throwing arm into the cocked position. The high gear ratio of the worm gear will significantly lessen the input force, and the self-locking nature of the worm gear will prevent the throwing arm from rotating uncontrollably if the handle were let go of midway through the cocking motion. To maintain the original functionality of the thrower, a mechanism was designed to disengage the worm gear so that the throwing arm can rotate freely to launch the clay target. With the gear train disengaged, there will be no additional forces acting on the thrower, and it will perform the same as the original. This guide here for the disengage mechanism also acts as safety guarding, and while not exactly representative of the final design concept, the additional pinch points introduced by the gear train will be properly guarded to protect the user from injury.
As a proof of concept, we created a 50% scaled model of our design in order to show that it functions as intended. As you can see, the clay pigeons were also scaled down so that we could perform a functionality test. For comparison, this picture shows the scaled prototype beside the original size device.
Alright, as you can see, the functionality on the top remains the same. All of the components of the original throwing arm are the same on the top. And then on the bottom, you have the crank, which is connected to a shaft which spins the worm gear here. And you have the disengage mechanism here, which is connected to the worm gear, which allows us, when it's engaged, it connects to the worm gear, which then you can crank the throwing arm, and the worm gear and the spur gear mesh together to allow the throwing arm to crank in the correct direction.
As you can see in this clip, the functionality of the prototype is demonstrated. He engages the worm gear and then rotates the crank arm in order to move the throwing arm into the locked position. Once it reaches the locked position, he will disengage the worm gear in order to allow the throwing arm free motion to throw the clay pigeon. Due to the stability of our current prototype, the model will fall over. In our final design, it will be more stable and this will not happen.
The original torque required on the arm to fully cock the thrower is 50 foot-pounds. Using the relationship between the torques in this equation for a worm gear, with N equal to 20 teeth on the spur gear and eta equal to 60%, a conservative value for the input torque is 4.2 foot-pounds. An eta value of 60% was used for a conservative estimate, since worm gears are less efficient than traditional spur gears. With a 6-inch handle on the worm gear, this results in a maximum required force of 8.4 pounds by the user.
The original clay target thrower retails for $150. Based on our component breakdown and our estimation of material and manufacturing costs, each thrower costs about $80 to produce. Our thrower will retail for $165, or a 10% increase in the original price, leaving us with $85 to implement our modifications and make a profit. The cost of modification is driven by the procurement costs of the worm and spur gears. This cost is expected to be $40 per unit. The modifications can be mounted to the thrower with minor changes to existing components, and the Destaco clamp for the disengage mechanism and other components will be readily available and affordable in bulk quantities. The additions to the redesign are expected to cost a total of $50. This gives a profit margin of $35 per unit. This new product reduces the profit margin compared to the original. However, it should be appealing to more customers. This additional ease of use should give us access to a new market of buyers. People that cannot operate current manual throwers but cannot afford or are unwilling to buy more expensive motor operated throwers could have an interest in a manual thrower with an easier cocking mechanism.
Oh!